R3 equal to RB into RC upon RA plus RB plus RC. So what about the value of B and C? It is a 40 into 50 upon RARB, that is 30 plus 40 plus 50. Again denominators becomes 120. Again cut out with the 4 3s are 50 divided by 3. So R3 equal to 16.16 ohm. So using this equation we get the value of R1, R2 and R3. So very simple sum. By remembering the three equations we get the answer. So remembrance of the equations are very easy of star to delta and delta to star transformation. So we got three answer: 12.5, 10 ohm and 16.66 ohm. Okay, now question number 2. Question number 2 is compare electrical circuit and magnetic circuit. Also define the four terms. First is flux density, second reluctance, third is permeability and MMF. The first thing is comparison between electrical circuit and magnetic circuit. So let's see the comparison. Now first we understand what is the electrical circuit and what is the magnetic circuit. See here, what is electrical circuit? The basic resistance is connected with any voltage supply, then current I will be flow. Similarly, if we take one iron ring and if we wound any copper wire and then we pass the current, the magnetic flux established into the iron core. So it is called electrical circuit and it is called magnetic circuit. Now there is some similarities or there is some comparison between the electrical circuit and magnetic circuit. When we connect the battery or EMF, the current will be flow into the electrical circuit, but when we pass the current through the coil, the magnetic flux will be established, it will be produced, it can't flow into the circuit. So on based of these two circuits, there is some similarities given between these two circuits. So see in the PPT there is a 10 comparison is given. First is the closed path for electrical current is called electric circuit. In magnetic circuit there is a closed path for the magnetic flux is called magnetic circuit. There is comparison between magnetic flux and electric current. Current is always flowing and there is a closed path for the current, similarly closed path for the magnetic flux. Current always flow through the conductor while the flux is produced in the material. Flux always produce, it can't flow. The unit of current is ampere and unit of flux is Weber. Third point, we required electromotive force to force the current to flow in electric circuit. In any electric circuit we required the electromotive force, or we can say battery, to continuous flow of electron or electric current, and its unit is volt. While in a magnetic circuit the magnetomotive force is necessary to produce a flux in the magnetic material. The unit of MMF is ampere into turn. Fourth point, the property of material to oppose the flow of current is called resistance. Its unit ohm. And similarly in magnetic material also there is a oppose of flux. That means the material to oppose the establishment of magnetic flux is called reluctance, and the unit of reluctance is ampere turn per Weber. Resistance is given by rho L upon A. or L upon sigma A, while reluctance is given by L upon mu into A, or mu can be separated as a mu 0 mu r A. So here conductance equal to 1 upon resistance and permeance is equal to 1 upon reluctance. Similarly, in a electrical circuit there is a resistivity of material, while in magnetic circuit there is a reluctivity of a material. There is also relation between resistivity and conductivity. So conductivity is equal to 1 upon resistivity and permeability is equal to 1 upon reluctivity. Similarly, current is equal to EMF upon resistance, which we learn into the Ohm's law that current I equal to EMF V upon R. Similarly, flux is equal to MMF upon reluctance. And in electric circuit, current density is given by delta L upon A ampere per meter square. Magnetic circuit, flux density B is equal to phi upon A, flux upon area Weber per meter square. And similarly, electric field intensity E equal to V upon D volt per meter, or magnetic field intensity is H equal to Ni upon L ampere turn per meter. So these are the 10 or 11 points for the comparison or similarity between electric circuit and magnetic circuit. Now there is a 4 definitions are asked. First definition is flux density. What is flux density? The flux density is defined as flux passing per unit cross-sectional area through a plane perpendicular to the direction of the magnetic flux. See in the figure, there is a one cross-sectional area is represented and magnetic lines are passing through it. See, the magnetic lines are perpendicular to the plane. So density means what? Okay, how much flux passing through this cross-sectional area. So that's we written into the word that flux passing per unit cross-sectional area through a plane, and it is a perpendicular to the direction of flux. It always perpendicular to the direction of flux, and flux density is denoted by capital B. Unit of flux density is Tesla from the inventor, or we can also write out that Weber per meter square because it is a per unit cross sectional area. So flux is a Weber per unit cross sectional area, that means a meter square. So Weber per meter square is a unit of flux density. Second definition, reluctance. What is reluctance? The property of magnetic material to oppose the production of magnetic flux in it is known as reluctance. As resistance opposes the flow of current, similarly in magnetic material, the reluctance having the property which opposes the establishment or a production of magnetic flux. It also defined as ratio of MMF to flux produced in magnetic material. It denoted by capital S. Its unit is ampere turn per Weber. We can simply remember the reluctance S equal to MMF upon flux. That means MMF is equal to I into N, and flux is given by phi. So we can get the unit from this equation. MMF is magnetomotive force, unit is ampere into turn, and flux having the unit Weber. So unit is ampere turn per Weber. Next is permeability. The property of magnetic material to allow for the production of magnetic flux in it is known as a permeability. Permeability means it is having some property which allow to produce the magnetic flux into the material. That is known as a permeability. It allow the flux to pass through it. Permeability is denoted by the mu. Its unit is Henry per meter. We can denote mu is equal to mu 0 into mu r, where mu 0 is a permeability of air and mu r is a relative permeability of any material. It's a relative to the air. So mu is equal to mu 0 mu r. Fourth and last definition, magnetomotive force. As in the electric circuit, the EMF is necessary to move the electron or pass the current. Same way in magnetic circuit, the MMF is necessary to establish the magnetic flux. So as we discussed earlier, in magnetic material, if we want to produce the flux, then MMF is necessary. As in electric circuit, EMF is required. In magnetic circuit, we required MMF. The unit MMF is given by FM, or its unit is ampere into turn, or equation is MMF FM equal to I into N. Simply I is current, so it is given by ampere, and N is number of turn. So unit is ampere into turn. So these are the four definition which is also important. Okay, thank you.